Now let's go ahead and move forward here to the next problem. So in this example, same thing. We will start by reading the question sentence. Everybody, what are we trying to look for? What are we trying to obtain here at the end of this situation? What do we want at the end here? What is it that we want? Yeah, I see the word total for sure. That's definitely something we'll want to highlight. Yeah, now we got to add a little more context to it, right? We need a little more story with that because total could mean a bunch of different things, a bunch of different ways. But when we say we need how many pounds and ounces of flour in total, that makes a lot more sense. We want to know at the end the grand total of pounds and ounces. Okay, boom. Now that we know what we're trying to end up at, let's begin understanding what we have to work with. The way I like to think about it is, what do we want? The question. What do we have? The information. And what's the connection? Translating that English into math. So here we go. What we have here is a recipe calls for 2 pounds, 5 ounces of flour. Okay, let me highlight that right there. We have 2 pounds and 5 ounces for the recipe. And then what we need to do here says, if we need to make 3 batches of this recipe for a large party, how many pounds and ounces of flour will you have in total? Okay, cool. So let's understand this a little better because there's a couple of different ways we can do this, but there's a very simple way that we can go about this. Everybody, if we have 2 pounds, 5 ounces, how many batches are we trying to make? Yeah, we're trying to make 3 here. So pretty much what's going on here is we have this 3 times over. That is 3 batches. And when we add all of this up together, look at how friendly this problem actually is. So everybody, what's 2 plus 2 plus 2? What's that going to be? Yeah, that's going to be 6 pounds. Let's write that down right there. And then 5 plus 5 plus 5, what's that going to be? Yeah, that'll be 15. That'll be 15 ounces. Now, everybody, for the sake of being proper here, do we need to convert these ounces into pounds? Do we have enough ounces to convert into at least a pound? No, we don't. Pop quiz. How many ounces would we need to turn it into a pound? Yeah, we need 16. We're not there yet. We don't have 16. We have less than that. So this is actually already proper. This is already good. 6 pounds, 15 ounces is correctly stated. So we actually don't even need to convert in this problem. It was just a quick little scary for us because I am willing to bet, and y'all let me know in the chat box, and if you're watching this as a recording, just go ahead and just laugh it off to yourself. Who here was instantly nervous about this problem? Before you even knew what you had to do. Before you even knew that you didn't have to convert. See, this is what I'm talking about when I say basic strategy, the fundamentals, starting with the question, then the information, and then trying to understand the connection. When you stick to that basic strategy, my party people, you'll see that there are a lot more questions that you already know how to do. There are so many questions that you know how to do, but the fact of the matter is we just get in our own way. And that's what test anxiety is. That's what test anxiety is. And sorry about that. I highlighted A. It's supposed to be B. Excuse me there, everybody. Appreciate the patience on that. But I hope you all understand that when there's a fundamental strategy involved, you give yourself the best opportunity to stay calm, cool, and collected. Does that make sense before we continue? Sweet. Again, practice, 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 proper practice. Let's go ahead and give this one a shot. Let's go. No matter what, let's give it our best here. Step 1, first of all, everybody can do this regardless of your skill level. What are we being asked to find? What are we looking for, everybody? Correct. We are looking for time right here. What is the time elapsed, meaning how much time has gone by. So again, elapsed means, hey, look, how much time has gone by. So with that, everybody, we can all agree, hopefully, that we're looking for time. So we have that going on right there. All right. Now, step 2. Let's understand the information. Remember, it's not just about the numbers, it's about what the numbers mean. So here we go. 2 objects start from the same location and at the same time travel in opposite directions. Okay, again, 2 objects that start at the same place at the same time travel in opposite directions. So everyone, because of that right there, again, same place, starting at the same time, what do you think we might do when presented with the opportunity to interact with the rates or the distances? What do you think we might do? Correct. That means add all day. And I'm glad that a lot of us are using 14, 15, 16 Ds in the word add because we know it at this point. It's been drilled in. And this is going to help us as we continue practicing. So yes, let's keep reading here just to make sure we got all of our ducks in a row. Here we are. Object A travels at 30 miles an hour. Let me write that down. The rate for object A says 30 miles an hour. The rate for object B is listed at 20. And everybody, what did we say? When we have both of the rates, if we wanted to, we could do what? To describe how they're moving together. Correct, we can add. So the true rate, when we consider both objects moving together, the true rate at which they're moving apart is 50 miles per hour. Let me keep that there on the side and bring everything else back here. So we left off here. Let's keep reading. After a certain number of hours, again, the time that we're looking for, after a certain number of hours, the total distance between them is what? 250 miles. So we have our rate being 50 miles an hour, the total distance at the end of it all being 250 miles an hour, or 250 miles, excuse me. But there we are, everybody. If we're trying to find time in the distance rate time formula, we need the relevant rate and the distance, and that's what we have. The distance that they are apart is equal to the rate at which they're moving apart multiplied by the time for which they're moving apart. The distance that they are apart is 250 miles. The rate at which they were moving apart is 50 miles an hour, and that can help us solve for the time for which they're moving apart. And because of that, just like it was said in the chat box, are we working backwards here? We absolutely are, everybody. And that's how we're able to point out what to do in even a problem like this that might be relatively new to us. We can still handle it with grace because we know how to use the distance rate time formula. Everyone, we're working backwards. We'll divide both sides by 50, and there we are. Doing that, we cancel on the right side, leaving us with 250 divided by 50, giving us 5 hours. That is our answer. And booyah, my party people. There we go. We just did, again, a brand new problem, working backwards with multiple objects. But because we were able to understand the